Alright, in this video we're going to learn about finding the area of regular polygons. So we've learned to find the area of other types of polygons like triangles, parallelograms. Regular polygons are polygons that have equal sides and equal angles, and you can see a couple examples there in that picture. So the name of the game with this is we're going to take those polygons and divide them into isosceles triangles, and that's how we're going to find the area of the whole polygon. So like an octagon, you could divide it into 8 isosceles triangles. If you could find the area of one of them, then all you have to do is multiply it by 8. So we're going to start off practicing finding the area of an isosceles triangle. So I have a picture of a triangle below, A, B, A prime. It is isosceles. And the bottom length is 7.9, and the vertex angle is 72 degrees. So although it's already drawn as BC, what we're going to do when we have an isosceles triangle is split it in half by drawing the height. Now, this is an isosceles triangle, so the legs and the base angles are equal, and this is a shared side. So by hypotenuse leg, triangle ABC and A prime BC are going to be congruent, which means that these legs here have to also equal each other, AC and CA prime. So if we divide 7.9 by 2, we get that each of those new sides are going to be 3.95. So now we have a right triangle where we can find this leg right here, BC. And for the whole isosceles triangle, that's the height. So we already have the base, so area is equal to base, which would be 7.9, times the height, so I'll leave that blank, divided by 2. Now to find the height. To find the height, we need to use these angles. So not only are those two legs that I highlighted in purple equal, but this vertex angle also gets split in half. So this angle right here is 36, which means this angle here would have to be 54. So now we have that red isosceles triangle where we could find the height by doing SOHCAHTOA. So in this case, we have the adjacent leg to 54 degrees, and we're looking for the opposite leg to 54 degrees. You could have used 36 as well. It would have been just fine. So the tangent of 54 is equal to h over 3.95. If you did the tangent of 36, well, that would have been 3.95 over h. Both of these answers, both of these setups would give you the same answer. Now when we cross multiply, I'm going to put tan of 54 over 1. H times 1 is h. And then tan of 54 times 3.95 comes out to 5.43. So now we can plug that in right here for our height, and we could find the area of that isosceles triangle by doing 7.9 times 5.43 divided by 2. And that comes out to an area of 21.4 square units. So that's going to be the main part of this process, is finding the area of an isosceles triangle. Sometimes you'll split it into two right triangles that aren't special. In that case, you do SOHCAHTOA. And if this came out to be special, like a 30, 60, 90, then you can use properties of special right triangles to solve. So in the example that we just did, we were given the sides of the polygon. So what do I mean by that? If we divided this pentagon into triangles, we knew the base of those triangles, which are the sides of the polygon. Some other important vocab are the height of those triangles. I'll highlight those in red. That has a word called apothem. So sometimes you're given the apothem, sometimes you have to find the apothem. I don't know why it has its own word. I don't know why you can't just call it height of a triangle. But pretty much when you inscribe a polygon in a circle, the perpendicular distance from the center of that circle to one of the sides is called the apothem. And that's going to be the height of these triangles. Alright, the center of the circle, if we inscribe the polygon in the circle, is called the center. Alright, so it's also like the center of that polygon. And then what's not listed here, but it's also important to know, is that these sides of these triangles are called the radius. And if you inscribe it in a circle, you could see why. Those purple lengths, radius, that's also the radius of the circle. So in any type in any of these questions, or find the area of a regular polygon, you could know the green parts, you could know the sides of the polygon, and you have to find the height of the triangles. Or maybe you know the height, and you can use that to find the sides of the polygon, the green parts, which are the base of the triangles. Or maybe you're given the radius, and you can use SOHCAHTOA to find the height and the base, or the apothem and the sides of the pentagon. Alright, so any of these three, one of them could be given, and you can use what you know about angles and right triangle trig to find the other two sides.